Ihr hört die Erium Podcast, der Data Science und Machine Learning Podcast für Studienabsolventen und Young Professionals.
Today's guest on the Erium Podcast is Dr. Jean Metz. He works as a senior machine learning engineer at GfK in Nürnberg. He is the tech lead of the forecasting end-to-end team responsible for delivering reliable and scalable machine learning models into production. Jean Metz holds a PhD in computer science with a focus on machine learning. Previously, he worked in several domains such as bioinformatics, finance, energy, or international public transportation. He also had the opportunity to work as a computer science university professor and researcher in distinct Brazilian universities. The exposure to this variety of domains and roles, combined with his passion for data-driven solution and coding, makes an excellent set of ingredients to one of the things Dr. Jean Metz likes most: to learn new concepts, tools, and techniques to make his work more efficient and effective. During the cold European winter, he hibernates. From spring to autumn, however, he spends the weekends cycling or hiking around the Nürnberg region or enjoying a good cup of espresso coffee in one of the espresso bars in the city.
Welcome to this new episode of the Erium Podcast. My name is Theo Steininger and our today's guest is Jean Metz. Hi Jean, nice to have you in the podcast.
Hi Theo, thanks for having me. It's a pleasure.
I was very looking forward to this conversation. I think we have a lot of topics to discuss. As we heard in the introduction, you are very experienced now working at GfK in Nürnberg. Could you give us an idea and explain again a little bit more what does your work at GfK look like, and actually what is GfK doing for all those listeners not knowing the business field of GfK?
Okay, so maybe I could start with the GfK short description. Basically, GfK is a marketing research company which provides solutions for companies and some customers in terms of to understand what the market looks like, trying, for example, foresee what's going to happen if in a certain event on the calendar, like Christmas, price drops or demand, and so a lot of information regarding the marketing of deliverables and products in general, electronics, and we also have a big data set, let's say, of information that is delivered by those customers, from where we can extract and data analyze this data and extract information, create insights for them, so to help them drive their business and create more value. As for me, I'm currently, as you said, a tech lead of a forecasting end-to-end team. So I basically try to keep the boat on track. I do work also with some technical tasks like coding. Being a senior machine learning engineer, I'm also the one that's responsible in the team for the boring tasks and sometimes the difficult ones. But let's say that half of my task is to help the team to keep in the path and to deliver the proposed solutions we create, and thus maintaining our stakeholders happy.
Mm-hmm, mm-hmm. And could you tell us a little bit more about the team? We had it that teams might be set up very homogeneous, very heterogeneous. How is your team set up?
My team, being an end-to-end team, we work on the customer-facing features, let's say, most of the time, right? Mm-hmm. So we have currently 3 front-end engineers, 2 full-stack back-end engineers, and 1 QA engineer. and also two machine learning engineers. One of these is me. So I have a colleague, another machine learning engineer who helps me there to make this bridge between the software engineers and really the technical part with the data science aspects of our work.
All right. And like in this position, you have to take care that everything goes into the right direction. So you also have to understand what the work of your team members actually is, right? And a position many data scientists are going into is, okay, you leave university, you're a junior data scientist, you have like a rather narrow field of responsibility, and then you start conducting projects by yourself, and then you maybe even level up one step more, then you get team responsibility. And many data scientists have a very strong statistical background, mathematical background, but not that of a big like software engineering background. So the question people often approach me is, hey, Theo, what do you think? Do I need to learn more about, for example, front-end development or like back-end development? What about like DevOps? Do I need to know the Docker commands, how to set up a Docker Compose scenario? Or is it okay if I just read through the Wikipedia articles on the other extreme to get the basic concepts? So maybe you could explain to us what your approach was, also with your educational background, having a PhD in computer science, also math related, and how you would say that this and this is important, and maybe this and this is not needed in order to being in a good position to really lead your team in a qualified way.
Yeah, definitely. My story is kind of unorthodox, let's say, because during the time I was pursuing my PhD, I was really focusing on machine learning, analyzing data, understanding algorithms, defining algorithms for machine learning, right? But at the same time, I had to pay the bills, right? So I was working as a backend software engineer, and it was a completely different subject. So I worked with C and C++ development back then. So after finishing my PhD, I decided to pursue academic career. So I applied for a professor position. I got that position, and I worked for 2 years on that university. Obviously, I had focusing the opportunity to focus on research. It was purely on machine learning. We created a group of AI research in that university and so on. But one thing that I always felt, and you actually described, is this thing that, whenever I need to create something, to create a product or to really validate my research ideas, I am stuck in a box that I can't actually connect to others.
Mm-hmm. Yeah.
And that curiosity made me rethink my career path. Mm-hmm. So I applied for a position as a software engineer. So I just gave up that academic career, let's say, to go on and work on the wild, on the industry, as I usually say, and then get this hands-on experience on how software is really, really developed on the wild, and how I could transform those research projects into something that becomes a product and can be used then and impact people. That was the target. I then worked for a few years as a backend engineer, and slowly started going back to the machine learning and data science field again, with this baggage, or with this backpack full of tools from the engineering field, and now bringing these skills into data science. And I really believe that having this kind of profile, as we normally call it, a T-shaped profile, where you are still a specialist on something, but you also understand how the other components look like and how they should work, that really helps you on deliver better value. In the end, in data science, we question data, we experiment, we have a lot of ideas, but if you cannot transform this into a software that really, really runs and connect and integrate with the other components in your organization, there is no value. And that's the reason I think that people should even being a data science mathematician, sometimes statistician, still try and understand how the whole pipeline works and how things get connected to each other.
Yeah, I think the understanding is definitely necessary. From your perspective, is it advisable to really spend weeks and months to get oneself's hands dirty, also going into the front and back end DevOps direction? I think it was like the jackpot for everyone, and especially yourself, that you have like the super, I would not say it's a T-shaped expertise you have, it's like a box-shaped expertise. Yeah.
Yeah, I think that you get a lot of opportunities of learning this on the job. It's also a matter of being open to learning. It's a mindset thing. I've worked in the past in several projects where some of the data scientists, they were super open and curious, and they want to understand how the tools work. They are not really coding there or writing the scripts themselves, but they want to understand. And the fact that they are on the daily basis talking about this and looking at those codes, they in the end absorb this knowledge anyway. And this only makes you a better data scientist. You're still going to focus on the modeling aspect, the data analysis aspect, all those things, or the difficult parts, the black magic, as the software engineers usually call it, right? But on the other hand, you know the whole pipeline, and more important, you know what the model that you are developing will do in the end and how it's going to be integrated. So this ability of learning on the job, this opportunity you have on an end-to-end team to really see how things work, this just adds other set of tools to your job.
And sticking to this imaginary picture of the T-shaped expertise profile, I like this one very much. Where do you put the most effort in, and which part of this T? Because like, if you look at the archive, a paper about machine learning, like being from 2020 nowadays, maybe even outdated, or at least considered old. And at the same time, also in web technologies, in the field of web technologies, you have so many new frameworks, technologies, approaches, design patterns that it's hardly manageable for a single human being to stay up to date in every single aspect of like a T-shaped expertise profile. So what is your individual, your personal approach? Do you focus on like the vertical bar in the T to really improve even more in the in your specialization, or is it a little bit of everything? Yeah. What's your approach there?
Well, first of all, I completely agree. It's impossible to follow up everything. So you have to focus, right? So the vertical bar, which is where you put your effort, the most of your effort, is actually focus on your strengths indeed. So you have to keep up with what is published, and it's even if you really focus on, let's assume you are an NLP specialist, even trying to follow only this small, quote unquote, field in machine learning is extremely hard. But you have to focus on your strengths, obviously, but always keeping in mind what's your current situation in terms of the problem you're trying to solve. Right? What's the business problem you're trying to solve? And then understanding how the other aspects of the whole pipeline or the whole platform you work on, it's also important. But you don't need to really dive into details. It's always helpful to know it, to have a good overview of how tools work, and especially concepts, how it works. For example, if you are a data scientist in a company that's really engineering tech driven, for example, Google, Meta, all those companies, which are engineering companies at core, data scientists are expected to understand the concepts of programming in general, not only how to use NumPy library, right? So understanding object-oriented programming, functional programming, all those things, doesn't mean that you will be writing these kind of codes all the time. You have to spend the time obviously researching for a different method or analyzing data to deliver on the solution you are proposing for a specific problem. So focusing on your strengths is one thing, but also spend a little bit of time on understanding how the rest of the tools and techniques works. More important, the concept. And one thing to never forget is understand the domain you work on, because even if you are a unicorn, you're the best programmer ever, right? Let's assume that this mythical creature exists. You are the best programmer ever. You are the best mathematician. You are all the best everything. If you don't understand the domain, you can't create a solution for it. So really, it focus on why am I doing this kind of work? What is expected as a result? What happens if I, change this particular approach to this problem? If you don't understand the domain, you can answer those questions. And they look simple, but in practice, they are not.
And by this, you mentioned something very important. Like it's not only about technology and tech problems, but it's also a task and a problem to solve to understand the domain you're developing a solution to. We had, in our own experience, I had in the discussion with podcast guests, various like problem fields. You must be careful. It might be legal. It might be stakeholder and shareholder management at some point, even keeping everyone on the same page. Might be creating multiple small solutions in a very short time to give orientation and inspiration. And this was more than like a creative process, not a technical one. Like looking at, again, maybe the T-shape profile of those various challenges that you face. Is there one challenge or like one category of challenges that keeps you busy the most? Is it technology, or is it maybe like the mood of the team, or I don't know? Like, is it communication? Yeah. Can be everything, right? So, what is it in your case?
Challenges, they come in buckets, right? You don't have only one challenge. Like every day, you have a different one to deal with, and to take the opportunity to learn from it, right? So for me, currently, every project I join has a different set of challenges. The technology aspect of it, I don't really mind because I'm very curious. So I actually sometimes look for it, oh, I don't know how to do that thing, so let me try and if I can find a spot on my agenda to actually get that task for me, and with some support at least to try and understand, that's good. I'm happy with that. But one thing that is definitely in a more general aspect is definitely a challenge for most of the data science related projects that I was involved with, is the quick access to data. So I think that when you have a more data-centric approach to this kind of projects, and an ideal world, you would have super nice prepared data sets, or let's say different data sets available quickly and readily available for you to experiment with. You can focus on the business task you want to solve, make the questions, torture the data somehow to look for this and deliver value. So this is one aspect. It is really difficult, and in several companies, to have this data centricity in place. So we always, for certain aspects, you have the data. For sometimes for certain parts of the project, you have to do it yourself for the data preparation, cleaning, and those things. So this is a technical aspect that I think is a challenge to keep up with the pace of delivering on a project or giving the results to your stakeholders, but the data is not there yet. And the other aspect, which for me is even more challenging, is the communication and collaboration. So that's not really technical, but how you make your team to work effectively, exchanging ideas effectively. You could say just schedule a meeting and bring everybody in, and everybody will be up to date. If you think in terms of the complexity with the lines, if you draw the chart or the graph that represents the number of channels in communication on a meeting with 5 people,
Oh, yeah.
it's big, right? So finding this balance of how to communicate properly, not lose the context, make sure that everybody knows what's going on, but only the people that really really need the detail are involved on that. It's really difficult, and make sure that the people get into this spirit of really teamwork, work collaboratively, create this safe environment to people to make questions and share information. This for me is really challenging. It's a part of my work that I really enjoy it, but it drains a lot of energy, let's say.
Yeah, indeed it does. Yeah. You mentioned data centricity, and a very interesting thought that I wanted to share on that part is that it's like a disease. People leaving university, they get a data set in an industry project maybe, and then they take the data set for granted and try to
Exactly.
squeeze as much as possible from this given data set by tuning the models even more and more and more and more. And the approach of saying, okay, let's leave the model as it is and put some effort in creating new data that might have deeper or broader information compared to the initial data set is like something like a thinking out of the box approach for them. But it should be very natural, right? To not only optimize the model and the accuracy or the hyperparameters, but also have a look at, okay, what can we do on the data side? Come on. Yeah.
We came a long way at improving our models. All right. There are so many optimizers out there. Sometimes it's even very difficult to choose from because the options are almost endless. And a lot of people focus on, let me change this parameter a tiny bit. Let me run another round of grid search and spend a few hours or days optimizing this and that. And this changes, I don't know, 0.0001% in your performance metric. On the other hand, people keep the data untouched because we are trained to do that in academia in general. As you said, we are given a clean data set. We don't have to actually create it, and don't even do any kind of preparation. And what I meant by data centricity is not only having the data available easily and accessible for data scientists and machine learning engineers to experiment with. And maybe you start with a set of features, and then you see that maybe I could include an external source of data here, and then you have this in your data lake or whatever kind of tool that you are using for this to store this data. And you can just pull in this new set of features, glue things together, and start doing your optimizations, right? But data centricity, the way I see it, is a little bit more than that. Is, as you said, like focus on your data. You can keep using your algorithm the way it is there. Make sure that with the least effort you deliver more than 80%. If you think about the Pareto rule, right? And with that effort, and then maybe you can work a little bit harder on your data. Feature engineering, cleaning, preparing it. Make sure that you have data lineage in all of the steps of your pipeline. You can check whatever you are using in the first step and how this affected every single step in the pipeline.
You just mentioned the pipelines you're working with, and as we heard in the introduction, you are responsible for the end-to-end team. And at that point of time, I'm super curious, how do you define end-to-end? So you already said you have like those front-end developers in there. So this is like already a first piece of implicit information, in which direction this goes. But could you explain a little bit more? What does end-to-end mean for you?
Yeah, definitely. I get the confusion because actually every company use different acronyms or the same acronym for different concepts, right?
Yeah. Right.
So what at least in GfK and also the way that I see the end-to-end is a team that has every profile available on that. So meaning you can theoretically from the get-going, from the idea inception, develop a POC, go to the next phase of an MVP product, validate, put in front of your customers, validate this, and start improving and get this into production. Focusing on also scalability, performance, security. So really developing from idea to the real application running in front of the customers. So that's why we have front-end engineers. We have also data scientists involved. In GfK specifically, at least for this domain which I'm working on now, forecasting, Endtoend team is one team in a domain which we call predict, responsible for developing more prediction projects, let's say, or products. We also have discovery and research teams. So currently I'm working in collaboration with two research teams. So these teams, they are mostly comprised of data scientists, but we always have support from DevOps engineers or SREs to do this also black magic, hard tasks on the operational side, right? But then these research teams, they work somehow on creating these ideas, torturing the data to come up with solutions for products. And at some point, there is a handover to the Endtoend team to actually get this POC and transform this into production. And this handover is something that we have been working hard to decrease as much as possible to make sure that the teams work closer and closer, let's say. So as an Endtoend team, we then will get this and work not only into get this code, that this proof of concept, and just make sure that it runs in pipeline. That's not what we do. We transform this code. We make sure that it fits in the whole architecture and integrates with the other components. So as an Endtoend team, you also have to focus on how the work we do will impact the other teams, right? So we use the same infrastructure, the same application. In terms of the customer-facing application, is the same application, but there are so many components. And if you look back at some years ago, Google Research published a paper on the pipeline, and there is this infamous diagram with a lot of boxes, and there is one tiny box there, a black tiny box, which is the machine learning or the data science. And that is a very nice picture because it illustrates what we see in an Endtoend team. Usually the research team is focusing on that tiny box on machine learning. And that's my point on the Tshaped also, that they should know, or ideally they would know how this thing is going to integrate with the other boxes. In the Endtoend, we actually take care of the other boxes too. Make sure that they communicate properly and that the data is there when it's requested, and then that we can process it properly in a timely base. So this is also an aspect that usually in research you don't put too much effort into, which is I'm validating an idea. I have maybe 4 weeks to work on this really fancy idea, or maybe 2 weeks. So you don't put too much effort into scalability aspects. You fetch the data somehow. Someone tell you that the data is in the database or in a potentially in a storage bucket. You do your magic, and that's it. You validate the idea. Once that the idea has proven to have some value, then it's time to make this run in the real environment. So that means time constraint is important. So for some projects, you have 10 minutes as a hard time constraint to train models. For some projects, you might have days as a maximum time. And this is what the Endtoend team has to step in and make sure that we bring that solution, but still respect our stakeholders' constraints in terms of costs, performance, and also the quality of the results.
And to understand this in more detail, those ideas that are evaluated and just tried if they could work in principle, are they customer specific? And does it stay customer specific when the end-to-end workflow kicks in, or does there even like the abstraction workflow take place that you say, okay, this is a good idea. It may come up in a discussion with a specific customer, but let's include this in, if I understood it correctly, you have the GfK Neuron Predict framework, the product, right? So will new ideas end up automatically, to phrase it like that, in the big solution, or is this then another step that needs to be taken?
There is always different ways of also coming up with new products, right? So one of these approaches is really stakeholder or customer driven. So there are requests coming from customers, right? Or even from the end-to-end team perspective, there is requesting coming from our stakeholders that, this interface between the real customers from GfK and our customers. And they come with requests. We have to come up with a solution, right? Sometimes this request is very engineering heavy, not really data related, but sometimes it's not. For example, we want to model a different aspect because the current model is not really covering. How do we do that? So this is the responsibility. Is this moment where the end-to-end team gets together with the research teams to look for a solution, right? And that which is more data science heavy for that. And we have this cycle of validation to validate this idea. And once our commercials or product partners are happy with that, then this has a kind of life phase in terms of going into a better feature on the platform. Customers can start using, and we get early feedback. And then while we are still improving this kind of product, the other approach is think like this. You are in a data-driven company. So in a normal situation, we have breaks for going to pick up a cup of coffee, and that's very common in a bunch of data scientists and machine learning engineers. This 5-6 geek guys and girls. We are going to talk about the issues that we are facing. So that's kind of a pool of ideas, and we also have what we call committee of practices in GfK, where some people get together to discuss specific topics. So one committee of practice we had in the past, I think it's still running, is optimization. So every 2 or 3 weeks, there is a kind of a meeting or call where people get together to discuss one specific approach, and or I'm having this issue, can I use optimizations to sort it out? And from this, it creates even more ideas. So assuming you have an idea, you can pitch these ideas to product or even to the data science council, as we call it. And if this idea turns out there is any value for the customer, or we believe that could improve the product, then we start a POC phase. So we actually develop a product, a proof of concept. And if this then is approved, we go through the next steps of productionizing it until it gets into the platform. So there are different approaches on how we bring new features and how we play around, let's say, with ideas to transform this into a real product feature in the Neuron platform.
Understood. Yeah, of course, it's a smart way to have multiple attack angles to add more features, like internal, externally driven. Nice to hear that you found also like a global set of processes to establish that, because nothing is more frustrating if you have a good idea but no process to pitch the idea to a committee having the power to also do some funding on it and enable people to just try it. Yeah, very good.
Also, there is the other aspect that I don't remember who said that, but it's like we hire smart people so they bring a solution, not problems, or something like this, right? So if we always expect only, or we just react to requests from customers, that does not sound good. It doesn't look like a very successful business. We have to be also proactive and bring up, that's what innovation means, I think. You bring up solutions to problems that your customer didn't even know it existed, and and then improves their business in some sense.
Yeah, like various levels of satisfaction when working with a company, right? The lowest level is you tell them what to do exactly and they fail at doing it. Then like one step above, it's you tell them exactly what they have to do and they do it exactly as you told them. That's okay-ish. but like it's much better to just describe the situation you're in, and they bring new and fresh ideas and maybe even prototypes for solutions. So this is what a good
Yeah, this
collaboration
is
looks
what
like, right?
I strive for example, in my team.
What I try to motivate my team and also our stakeholders is to bring the team requirements and not solutions. And the reason for that is that I've seen in the past, I've worked in another project in the past where our project owner would always bring solutions instead of the requirements. So absolutely no flexibility or room for creativity on how to improve a process or even implementation wise, right? And we, at that moment, we started discussing how we can improve this process and get better solutions to a technical design, let's say. And obviously, this sounds obvious, but because it's something that I actually experienced in the past, I said, from now on, back then I said, from now on, I'm going to always ask to our stakeholder, motivate them to always insist on only bring us requirement, let the technical team to come up with the technical solution for that. And this is what I also motivate to our engineers, especially the least experienced ones, because we also have juniors engineers, joining the team every now and then, to get into this flow of not only expect that you get requirements only instead of solutions, but also do not ask for solutions. Ask what is the problem, try to understand the problem that your stakeholder is giving to you, and then technically we can discuss in the team on how we are going to implement the solution for that, right? So that's something that I really think it's important, and not everywhere you get it.
Yeah, I totally agree. What I learned on the way, like moving from, okay, the tech team just gets like templates for solutions and they then do just the implementation or the coding, going to this where you empower your tech team, right, to come up with the solution by themselves. It's a challenge then for itself. I had to learn to find the right balance between those two extremes, because I'm now exaggerating, but if you have like an intern, the intern is not interested and not capable of like getting the big picture with like the company strategy being involved. But on the other side, if you have like your senior or like the head of development, of course, this role needs to understand the big picture and the strategy. So from my experience, definitely it's advisable to have more empowerment than less. But be careful to also have an eye on the people, not to giving them too much of a burden.
You're absolutely right.
To understand everything in every detail, because then they don't have any time left to focus on the solution.
And that's another reason why I keep saying team. Because I really believe in really teamwork and collaboration, and so working together. So from the stakeholder perspective, please bring me the requirements and what's the problem you have. And then from team perspective, we are going to discuss what solution. And obviously, then it comes to these different phases on your career. You will not expect that an intern just coming from the uni will understand the whole picture and the whole architecture and come up with a brilliant solution for that. But he might have something to contribute to, because we take for granted sometimes simple questions and we forget about that. And those simple questions, they make very big differences. This week, for example, we had a discussion in my team where I understood the requirements one way, but another colleague had another interpretation.
Oh, wow. Yeah.
So it was great that he actually said, no, it's wrong. And we started this discussion, and actually he was right. My interpretation was completely flawed. I was oversimplifying the problem. So that's my point of thinking about what the problem you have, and then joined with your technical guys, your buddies there, your team. Let's discuss on how we can break down this requirement and create really technical tasks to deliver the solution for that. And if you don't have that much experience, you might not know how to actually solve it. But if you understood the problem, you know how to question it. So that's my point.
Indeed. I very like, and I like the team aspect very much. That you say team empowerment does not mean that you empower every single member of your team in the same way and on the same level with the same responsibilities, but it's a team effort. Yeah, very nice, very nice. Jean, let's have a small break here and dive into like rapid fire questions.
Those
If
are
you
always
like,
difficult.
yeah. But rapid fire is relative, so you can answer as elaborate as you like. But the question itself, it should be short. And the first short question I like to ask you is, if you have a favorite algorithm and why. And it does not need to be like a machine learning algorithm. Can be anything.
Yeah, I actually have. I fell in love with an algorithm in the past. It's called Birch. It's a clustering algorithm.
Mm-hmm.
First time I saw the algorithm, it was, first sight love, because it used such an elegant solution to solve a big problem. It's tailored to scalability. On clustering is a very simple algorithm, but it uses a fundamental data structure to solve it. This is scalability issue, and that's why I like it. So go back to the basics, to the concepts, and to the fundamental data structures that we use, and use it properly to solve a real problem you have there. In this case, is a KD3, which is normally used for databases, and it's employed for a clustering algorithm. So I think it's a very elegant one.
So I don't know this one before. This means you restructure the data in the first place?
No, it's the data comes in exactly the same way as you would use for k-means.
Okay.
But the way that the data is represented in memory to represent the clusters, it's by using a KD3. So every internal node of this hierarchical clustering representation, it's actually represented by a node that summarizes parts of your data instead of having every data point as one element on that. So your dendrogram would be, let's say, huge. It's much smaller, and thus you can scale to much, much bigger data sets.
Nice. So the name was Birch, right?
Yes.
Okay, we have to put the link in the show notes. Okay, you have to keep a note on that. Next question. I learned that, or at least it was my impression, that you really focus on the solution, like on the result and the outcome. But nevertheless, is there still a technology stack that became like standard for your work, like old friends you use in the end and all the time? Or is it something new completely? Something completely new every time?
Weirdly enough, there's none. What I mean is I really focus on what's the tool I can use for this particular project. So currently, at least in GfK, currently I use the usual suspects for machine learning, like Python, scikit-learn, XGBoost, TensorFlow, and all those things. Really, really standard. And in terms of cloud solutions, we use Google Cloud Platform for this project particularly. But I really don't mind. In the past, I used for years Java, even for machine learning projects. My PhD, for example, was everything that I implemented was Java, even though I was working with hierarchical multi-label classification. So I really don't mind. It's like what can bring me the value in an easy, faster way that I can validate and I can write it properly. So maybe next month, if I change project, I'm going to use something completely different.
Completely different without looking back.
Well, yeah, kind of, because it's not really without looking back, but every time you spend some time on using a tool or a programming language, for example, you always carry the knowledge, right? And if I now change, for example, to use Haskell, which is a language which I have never used it, but the paradigm is completely different. I'm still gonna carry all the knowledge I have from the object-oriented paradigm of programming languages, or even from Python, and there I'm gonna mix with the knowledge I will learn with Haskell, which makes me a better engineer, right, in the end. So that's the point of don't get married to technology, but actually make use of it and learn as much as you can.
I think that's very important, because otherwise there's a danger that you have a hammer and you get so familiar with that hammer that everything looks like the same nail. And
exactly.
I years ago, I read about a story. It must be happened decades ago, but there was like the job to design a space station. Like this was back in the days where there weren't any space stations. And this task was given to a group of engineers, usually designing car tires. And the result was a space station with a toroidal form, like a torus in space.
Yes.
And the fun thing was they just replicated, or like they rebuilt what they built every day, like torus shaped thingies. And in the end, they found so many good reasons why a space station should have exactly that shape that there was enough justification to go with that approach. But obviously there was a super strong bias coming from, just randomness in the end, right?
Indeed. We are always prone to get this. I worked with a colleague also in the past, which has a background as a database administrator, or as we would call in the end, DBA. And he obviously has a tendency to always solve things on that environment, on inside of the database that he's using. It's like SQL, RDBMS, so really SQL-based database, for example, Oracle or something. So even machine learning tasks you can run internally on a database if you have the correct plugin. For example, Postgres can run any Python code you write with. So you can execute that straight away, right? It's good. And there are advantages of doing that in certain scenarios. And once he showed me a prototype he was working on, the first question is like, if our data is already on Google Cloud Platform and we have BigQuery there, why would we actually write down this custom solution, which we have to maintain? And first of all, learn how to do that from a database level using specific language, if we already have a solution that's really scalable inside of our data platform. So we also have to, think about that, the alternatives you have to solve that particular problem.
Of course, yeah. Dangerous one. So last question from the rapid fire session. So please complete this sentence for me. Artificial intelligence fascinates me because
of the unknown. Like, we don't know anything about it yet. We barely scratched the surface, right? So, and I'm really curious by nature. So I think that most of what we are doing is kind of brute force right now. If you think about it, you optimize an algorithm because you look at the pictures a billion times. While if you show the picture to a child once, he already understands what I think is. So it's like we are not really doing intelligence yet. But on the other hand, I'm really curious to see where we go from here.
Me too.
So the unknown fascinates me.
Yeah. Also on that topic, a few days ago, read an article explaining the differences actually between how machine learning and especially neural networks work in comparison to how brains work. And like fundamental architectural and conceptual differences you cannot just like tune away. And this illustrated very well from my perspective that, it's called AI. Often you have something to read like, inspired by the brain, blah, blah, blah. Yeah, but this only is true. It's true to a certain extent, but it's only true to a certain extent. So I'm also very interested in where this goes. Maybe quantum computing will introduce.
It's going to be a different paradigm, right? We have to learn all over again.
So I'm very curious about that one, and also like the timescales that elapsed. The machine learning efforts. I don't know if you include all the mathematical development, maybe 200 years with the statistics and stuff, compared to how long humanity exists. Yeah. Anyways, getting philosophical there. Let's jump back to your end-to-end team at GfK. At GfK, I'm very interested in the team aspect and how you manage to really empower the team, as we discussed before. And my question is, do you see a specific role that must not be missing? Otherwise, it does not work. Or is it like a big puzzle made up by the right pieces, and every piece must fit by itself?
Okay, so this is a very interesting question, the way you put it, to be honest. If we come back to the T-shaped description in the past, a person might not be specialist in something. So, and let's assume you don't have the budget to have a complete end-to-end team. So you don't have really a back-end engineer there, but you have a full stack guy that can work on the UI, understand how the web applications work, but also can give you somehow in the backend part. So this colleague or this team member has also already some familiarity with that, so he can work on and improve his skills and also solve this particular approach. It's not always true that you can deliver the same results, or even if you can deliver the results in the same speed. So the team will suffer, obviously, if you don't have a particular profile in your team. For example, you have a team that really works on forecasting, which is our case. And let's assume that for whatever reason, you don't have a data scientist or machine learning engineer in that team anymore. Maybe because, COVID. And then you cannot really expect that an engineer that has focused his whole career on developing web applications and front end would dive into the modeling aspect and understand and modify that model, or even come up with a solution in a week. So that's a problem that you have to manage, right? On the other hand, the way I see the end-to-end team working on and how we empower that is more in the sense that take up the responsibility to make decisions, to learn and contribute. All right. So the empowerment is not really make sure that you only work on your tasks, but get involved, collaborate with the rest of the teams. Of course, you will still work on your particular specialty there, but also somehow ensure that the team grows together in terms of knowledge, business domain, but also technically. So sponsoring the juniors and mid-level engineers to, upskilling, learning new techniques, learning how to do the integration, which is a very difficult aspect, how to connect the dots.
Right.
And this is how I see that the end-to-end team should work or, operate.
Final question. Is there advice you would give to your 20 years old self?
Oh, that one is a really nice one. I think about this every day, to be honest. Why I have not done that? I think it's basically read, be curious, and be pragmatic, with a lot of focus on read every day. It's very difficult to keep up with the pace on the technology advance. I know it, but you have to also try and keep reading what's happening there, and not only the technical stuff, but also give some time to your brain to digest some kind of other information, even fiction, romances, or I don't know, maybe leadership or product books that will somehow help you to broaden your scope. And while you sleep, if you get to sleep at all, your brain will create some connections and improve the way you live in the end.
I can only second that one. Jean, thank you very much for this conversation. I learned a lot. I hope the complexity masters out there learned a lot. Very impressive. I wish you all the best and great successes in the future from combining your expertise from those various fields of competences. Yeah, I hope we could meet in the future in person. We are not that far away, working offices in Munich and Nürnberg. I would love to meet you and wish you all the best.
That's great. Thank you, Theo, for having me. Let's go somewhere on a beer garden in Munich someday.
Oh, wow. Nice. Yeah. Gonna invite you to that one. All right. To all the complexity masters, have a look at the show notes. We're gonna link the Birch algorithm in the show notes. Try it out, give it a try, and maybe you also fall in love. Master the complexity.
Um auf dem Laufenden zu bleiben, folgt uns auf Facebook, Instagram, Twitter und LinkedIn. Wenn ihr uns unterstützen wollt, gebt uns eine 5-Sterne-Bewertung auf Apple Podcasts, folgt uns auf Spotify und empfehlt uns weiter. Bis zum nächsten Mal bei The Erium Podcast.